Let's get started. Good morning. My name is Pete Nicely, and I will be the person responsible for guiding you through this course, which of course is Introductory Chemistry. And I like to think of this course as basically a high school chemistry compressed in one semester. Want to sign the sheet? I'll take it. Okay, so the plan for today is that I'm going to go through the syllabus firstly, and then I'm going to go through the important links in Canvas, where we'll be using most of the materials and stuff. And then I'm going to go directly into the first chapter as a regular lecture. So let me get the syllabus on the screen. Okay, so as you can see on the very first page of the syllabus, some general information given. The course title, the course number and section, the number of credit hours, of course, my name and where I'm located. And by the way, I'm basically located between two campuses, this campus and the Ocala campus. So my location at the Ocala campus is in building 2, room 218C. At the Citrus campus here, I'm upstairs in room 208E. And my office hours are given here, and I just realized that there's one slight error. Let me make a correction here. And that is that. So I'm going to make a correction and then upload the corrected syllabus in Canvas. Anyway, the correction is that in addition to being in my office at Ocala on Mondays and Wednesdays here, I'm also be available by Skype. I'm going to say more about that shortly. So I'm going to make that correction there and then make sure that the corrected syllabus is uploaded into Canvas. And of course, the meeting time, the meeting location, meeting dates, my extension, and my email address. But let me just say this about my college email address. If you want to contact me by email, I very much prefer that you do so through Canvas, right? Canvas is a better way of doing it because for some reason, which up to now I don't understand why, if you send me an email from your Patriot account, it goes straight to my junk folder, right? Even though it's still a part of the CF system, but for some reason that's what happens. So if you want to send me an email, make sure you do so through Canvas. Another reason why you need to do so through Canvas is that when you send me an email through Canvas, I can see which course of mine you're enrolled in, right? And therefore, as a result, I can communicate with you better about whatever issues that you may be having or whatever, right? So if you want a prompt reply from yours truly, make sure that you send me an email through Canvas, right? And I typically take no more than 48 hours to respond. Usually 24, but sometimes 48 hours. What else? Let's see here. Oh, so let's talk about the Skype, right? I require my students to obtain a Skype account. There's a link which is provided, and you go there and you create your Skype account. And then if you have not done so already, and then what you do is send me a Skype contact request. My Skype address is given. If you see a Clearwater, Florida address associated with that, that's me. I'm just not gone around to changing that yet. So make sure that you send me that contact request. And make sure when you do that, that you include your name and the course, or at least the course number, all right? Because I want to distinguish between my students and people trying to sell the stuff, right? So make sure you include your name and your course or course number. And to sweeten things a bit, I'll be adding 10 percentage points to your first test only once you send me your Skype contact request, all right? And the purpose of doing this, as stated here, is to facilitate meetings between you and me. If you cannot come and see me in person during the office hours, at least you can contact me via Skype, all right? Okay, so there's a statement here concerning extended emergency closure. So from time to time, like what happened last semester, hurricane might be passing through, whatever, which may require the college to be closed. So therefore, if you want information about, what's going to happen when the college will be open, etc., you can call the numbers provided, or usually there's a banner at the top of the college's website, which gives you information about that, all right? Okay, course description. The course includes study of measurements, historical approach to chemistry, periodic table, gas laws, thermodynamics, excuse me, chemical stoichiometry, acids, bases, and redox or oxidation reduction reactions. And there's an additional statement here which we are required to include in our syllabi. It talks about the fact that you need to behave yourself in class, and also the fact that people might have different opinions that you might not agree with or even understand. Be tolerant of other people's opinion and all that. In chemistry, we don't encounter that many, controversial issues, right? So, it's very rare that we'll have, discussions where people have different opinions or whatever. So, however, we're still required, all of us as instructors, to include that section of the syllabus which deals with that, right? So I leave you to read that part. But as far as my teaching philosophy is concerned, I'm of the belief that the best way to learn chemistry, as it is to learning any quantitative based discipline, is that you engage in it by solving problems, right? In so doing, as stated here, you will develop critical thinking and independent learning skills, right? So what you'll find, and I think I mentioned it later on in the syllabus, what you'll find is that most of my assignment questions or test questions involves problem solving, right? So there's very little, if any, rote memorization required, right? I'm not a big fan of that, because in science, and I'm talking about, even if you go to advanced level research facilities, you don't see much by way of memorization that researchers will be involved in. It's typically just solving problems based on what they know before, right? And that's pretty much my belief when it comes to learning chemistry. So for that reason, I would give you tables, for example, with the periodic table for you to use in tests. I would give you a list of common ions. Some instructors I've heard require students to learn or memorize all the common ions. I don't believe in that. I believe I could give you the common ions, but you need to know how to use it in terms of solving any problems that are presented to you. And as stated here, by engaging in this way, it will serve you well, not only in your academic pursuits in college, but also after you graduate, right? So basically the aim is to develop critical thinking skills and independent learning skills so that you'll be able to function wherever you go after you graduate. This course is intended to prepare students for the general chemistry series of courses, which will be CHM 2045 and 2046. It says here those needing a less rigorous course could do 1032C or 1020. 1020 is not being offered this semester. I'm not sure what 1032. And the prerequisite for this course is this math course with a grade of C or better. And the textbook, I forgot to bring my copy of it so that you see what it looks like, is the Introductory Chemistry textbook by, oh gosh, the author is not here. Zoomed out. Okay, this is messed up here because this here should be for the required textbook. So let me make that correction. In the syllabus as well. Is that a text?
Yeah, I have it.
You can hold it up so that your fellow students can see it. So let me make this correction here before I forget. Right, so the name of the author is Zundal, and I think the latest edition is the 9th edition, right? So that's the required text for this course. Now, there's another book which is not required, but I would highly recommend it, and it is called A Basic Math Approach to Concept of Chemistry. And basically, this book is kind of like a workbook, right? They basically, if you look at each chapter, if I remember correctly, what they do is give a brief description of whatever the topic is or concept, and then it shows you some examples. and then it gives you more problems for you to work on, right? So that you become better at solving problems. So I would highly recommend it. Any student who have used this in the past, they have told me that they have benefited from it. So not required, but if you want to, you can get it, all right? Okay, and then there's a section here dealing with student learning outcomes. I won't go into that. I need you to read that. Basically, it talks about, basically what you should be gaining from the course. So let me move on now to assessment. You'll be given 3 exams. It says take home here. That's wrong. So that's not a correct one. You'll be doing those exams in the testing center. And each campus has a testing center. Let me see here. Did anybody? Oh, okay. Let me welcome those of you out there in Zoom. I completely forgot about you guys. So I'm sure you have heard all that I've said so far. So let me just say that the testing center will have your test available. Hold on 1 minute. Okay, I see the issue. Okay, right. So basically the way this works is that I would send a test to the testing center, and you can do it at any one of the testing centers here or Ocala or in Levy, depending on which one is more convenient for you guys, all right? And you do the test there, and then I collect it, and I grade it and get it back to you. And typically what I would do is that I would send it back to you electronically. We have been having some issues, especially last semester, at the tail end of the semester with the testing centers, where students of mine would go there and they are given the wrong test, right? So I'm going to do something different. I'm going to, whenever I write my test papers, at the top of the test paper, I normally put the title, like the course, the test number and so on. But I'm going to include the semester, because what happened last semester was that somebody from the testing center there at the Citrus campus gave one of my students, or pretty much all my students, a test from a previous semester, right? So I'm going to include the semester on the test, as well as the dates within which you have to do the test, so that there's no mistake. And make sure when you go to the testing center, make sure you specify the test, right? Introductory Chemistry for this semester, it should have spring 2025 at the top, right? So hopefully that will basically take care of that issue, all right? So as I said before, you'll be given 3 tests, each worth 100 points, and the lowest test score will be dropped, and you'll be given assignments during the course. I'll say more about that later on. All work must be done in ink, no pencils, and handwritten, and dates are given for the test, which are tentative, which means that they're subject to change again if something happens which causes me to change the schedule. I'll let you know so that you are aware of the changes. So we have the tentative test days, we have the final exams, and then below that, you see a description as to how each type of assessment contributes to your total. And now I see another error, because you won't be given any quizzes, you will be given assignments. All right, so no quizzes, assignments, right? So basically, exams will be worth 50%, assignments will be worth 20%, and the final exam will be worth 30%. And below, a hypothetical example is given to show how your grade will be calculated. So here we have a hypothetical student that has an average of 85% for the exams, 82% for the assignments, and 90% for the final exam. So what I would do, and this is already set up in Canvas, which I'm going to talk about shortly. So the way this works is that the 85% which a student gets for the average of the exams will be multiplied by 0.5 to give you 42.5, I'm sorry, out of a maximum total of 50 for the exams. In the case of the assignments, I'll multiply the 82% average for the assignments by 0.2 to get 16.4, which is the maximum, which is the 16.4 value out of a maximum of 20. And then the final exam, the person got 90% and multiply that by 0.3 to get 27.0 out of a maximum of 30%. And then I'll add a total of 42.5, 16.4, and the 27.0, and this gives 85.9, which is equivalent to a B grade, according to the college already established point system by the college, which is shown right here, right? So that's basically how your grade will be calculated. So all I have to do, because of the way Canvas is set up, or the way I set it up, I just put the numbers in, and the Canvas system does the calculation as shown here to give you your final average. So this is the point system, and basically you need to recognize that the grade actually represents something about what you would have gained from the course, or what you have shown me about what you have gained from the course. So as stated here, a grade of A in this course will imply that the student has mastered the full range of topics covered in the lectures and can very successfully apply these to solve the problems presented. The student can derive the important factors that lead to the best solution and makes particularly insightful contributions to class discussions. And it gives you some other information concerning the other letter grades. So so you need to understand that basically when you complete this course, the grade represents what, in my opinion, would be what you have gained from this course. I need to say something about the I grade, because in the past I've had situations where students believe that the I grade is basically an opportunity for them to delay coursework or to do more coursework to make up for any deficiencies before so that they can get a better grade. That is not the purpose of the I grade. The I grade is only given in a situation as described here, where you're not able to complete the coursework because of some unforeseen occurrences, like a death in the family or illness, whatever, right? So the way this works is that you would have to furnish me the evidence as to the reason why you're not able to complete the coursework. And then I have to pass that on with other paperwork, and the paperwork will land at the desk of, okay, there's another correction here, the Associate Vice President of Arts and Sciences. So he would have to sign off on it. And then we can make arrangements after that as to when you complete the rest of the coursework, and then the I grade will be replaced by the grade that you eventually earn, right? So that's basically what the I grade is all about. It's not basically something I can just give you and then you make up the coursework. Everything has to be above board. You have to show the evidence as to the reason why you need more time, and then I have to pass on that along with other documentation to the Associate Vice President of Arts and Sciences. Okay, so the next topic here is exams and assignments. And as stated here, exams will cover material from lectures, texts, and assignments. And in the vein of what I was talking before, most of the questions that you're going to encounter in your assignments and exams will involve problem solving, usually calculations, but in all cases, you have to show your work, all right? Each exam will consist of 3 questions, at least. I try to make each exam a question per chapter, right? And assignments will be posted in Canvas system and are due on a date specified. These must be completed by hand and either submitted in person or by Canvas. And I'm going to make a correction to that as well. I'm going to make all assignments be submitted on Canvas. So, so all assignments must be submitted on Canvas, and make sure when you do that, you submit it as a PDF document. That's very important because in the past, what I've found is that if you submit something in the form of, what's that, PNG, and there's another one which I can't remember right now. When I try to print it, it takes a long time. Well, firstly, it takes a long time to download and takes a long time to print for some reason, right? So basically, PDF is what I'm looking for when you submit your assignments in Canvas. Do not use PNG and JPEG, the other one. right? Don't submit your assignment as a JPEG document, right? Okay, this is not correct, another mistake here. So your exams will be proctored. As I said before, you're going to do that in the testing center. So I'm going to make that change as well. And then below that, you see the schedule. Of activities, right? And you'll notice that the first week, and I need to change these dates as well, but the first week will be an in-class lecture, and you'll be doing assignment number 1. But for the rest of the semester, what we'll be doing is that you guys will be watching videos for each chapters online. I've already published them. I'll show you where they're located in Canvas. And these are basically video lectures which will cover the different topics, right? And then we're going to use the class time for answering questions. In other words, if you, after watching the videos, if you have questions, I'm here to answer those questions. And then we'll go directly into your assignments where you could engage in problem solving. Of course, I'll be here to guide you along the way, right? So basically, this is kind of flipping the traditional way of instructing, whereas typically you'll have the instruction here, and then you do your assignments at home. It's a reverse. You'll be doing the lectures or watching the lectures at home, but we'll be doing the assignments here in class. And the reason why I structured it that way is because I think you guys will benefit with me being here, helping you to solve problems, all right? So that's basically how this works. So today, we'll be doing a traditional lecture based on chapter 1, but next week, you'll be watching the videos for chapters 2 and 3, and we'll be doing problem solving exercises for those 2 chapters next week. And that's basically the standing arrangement for the rest of the semester, all right? What next? So that's the schedule. Again, I think I need to make some changes to the dates. And then, of course, if there's any occurrences which allows or which causes some change in the schedule, I'll make sure you know about that, all right? So I'll be fair about giving a heads up in terms of any changes in the schedule. But I'll try to stick to the schedule as faithfully as I can. Okay, something I need to read to you here. College policies. The College of Central Florida is committed to help you succeed and achieve your academic, personal, and career goals. There are a wide range of resources, support services available to you. And if you connect with these resources and support services, then you'll be able to more likely succeed in your classes and complete your path more quickly. And here they get into talking about a system known as ESP, the Early Support Program. Basically, the way this works is that, let's say I notice that you have not been doing well in class, let's say you have missed a couple of classes, then what I would do is complete this form, and I don't remember who it goes to, but it goes to somebody, and that person will contact you and try to find out, okay, what do you need in order for you to stay on track? Do you need tutoring services? Do you need financial services, psychological support services, etc., right? So that is something which I would strongly recommend if you need help in these areas, that you take advantage of it, all right? Because we all want to see you succeed in your pursuit of your degree. Okay, academic integrity, cheating and or plagiarism will not be tolerated and may result in a special grade known as FF. And basically what that grade means is that you have failed the course due to violations of the college's rules concerning cheating and plagiarism. Now, that FF grade does not necessarily remain permanently on your transcript. If you attend a 2-hour seminar known as the Academic Integrity Seminar, then what happens is that, and by the way, there's a charge, you'll be charged, I don't know what it is, but after completion of that seminar, then that FF grade will be replaced by the grade that you will eventually earn. If you don't complete that seminar, then basically that FF grade will remain on your transcript, right? Okay, if you're a student with a disability of any kind, if you have not done so already, you need to report to the Office of Access Services And the way this works is that you go there and they determine the type of accommodations that I need to make for you. And then what they will do is email me a document, and the document will outline, if you need like more time on an exam, or if you need to go to the testing center in a more quiet location, or whatever the accommodation that you need will be outlined in that document, and I would have to make sure that those accommodations are met, right? Now, the person that you need to contact over there in the Access Services office is this lady, Cindy Frenda, and her email is not here, but the website for that office is provided, as well as the location at the Ocala campus, the phone number and extension as well, right? And then we get to a section here, again, I need to read you guys. Equal access, equal opportunity. The College of Central Florida does not discriminate against any person on the basis of race, color, ethnicity, religion, gender, age, marital status, national origin, genetic information, or disability status in its programs, activities, and employments. And if you have any further questions concerning the non-discrimination policies of the college, you may contact Carol Douglas Smith. She is the equity officer. Her location and her email address and her phone number extension are provided. Classroom decorum, disruptive behavior will not be tolerated. Disruptive students will be asked to leave the classroom. And if you continue to engage in disruptive behavior, then that will result in withdrawal from the course and further disciplinary action under the Code of Student Conduct. And then we have the CF Student Assistance Program. This is a program, if I remember correctly, it was adopted about maybe 5 years ago. And it's basically a counseling service, right? And the way this works is that if you have issues, personal problems, which gets in the way of your academic pursuits or your home life, whatever, there's a toll-free number which is provided here. If you call that number between the hours of 8:30 and 5 p.m., Monday through Friday, then that will put you in direct contact with a therapist, and that person will be able to help you from that point forward. Now, if you call that number outside of that time frame, then basically what will happen is that the therapist on call will be paged, and he or she will be able to call you back, and again, will be able to help you from that point forward, right? So, I would strongly recommend, if you need this service, take advantage of it, because I've seen situations where students have struggled and have had some issues, and they would have benefited, I think, if they take advantage of this. So make sure you do that if you need that help. Withdrawal. Now, let me just say before I read this that I hope nobody withdraw from this course, because my aim is to help you to succeed in this course. However, I understand that life happens and something may come up which makes it necessary for you to withdraw from the course. If you choose to do that, make sure you complete all the appropriate paperwork, all right? And make sure that they're signed by the appropriate parties, including myself, okay? That's very important, because in the past, I've had situations, I remember the first time this happened, where I had a student who came to class, I think, for the first 3 or 4 weeks, and then he disappeared for the rest of the semester. And at the end of the semester, when I'm putting in the grades, I look at the system and I see that he is still enrolled in the course as a normal student, right? And I remember the first time when it happens, I hesitated and I asked, if I remember correctly, I asked the chair, and he told me that just put the grade that the student earned. And I felt bad about it because, I kind of strongly suspect that something happened which caused him not to be able to complete the course. But I had no choice to give him the F, and that's how that worked out. And I'm mentioning that because of what is in the statement right here. Make sure that you complete all the paperwork if you have to drop out of the course, so that you won't end up with your GPA suffering, all right? Okay, what next? Some important dates. Today is Tuesday, right? So the only thing I see here that would affect in terms of class being canceled would be the faculty professional development day, right? Because MLK is on a Monday. Oh, and spring break. Right, spring break, of course. You have no classes. So basically for this class, that's it, yeah. The professional development day and spring break, okay. Let me see, what next? So the college reserves the right to evaluate individual cases of non-attendance. Students should be alerted to the fact that one, withdrawals do not count in CFGPA and may not be viewed favorably at the university level or for financial aid. Two, a withdrawal counts as an attempt under the forgiveness/withdrawal policy and the course repeat policy. Three, there are increased costs to take the course on the third attempt. And four, there may be a reason why withdrawal requests may be denied. And if you have any further questions, you may see the college's withdrawal procedures. And then we get to the equity statement, which I need to read to you guys. The College of Central Florida offers equal access and opportunity in employment, admissions, and educational activity. The college will not discriminate on the basis of race, color, ethnicity, religion, gender, pregnancy, age, marital status, national origin, genetic information, sexual orientation, gender identity, veteran status, or disability status in its employment practices or in the admission of treatment of students. Recognizing that sexual harassment constitutes discrimination on the basis of gender and violates this policy statement, the college will not tolerate such conduct. Now, let me just say here, stick a pin, that I've been here since 2011, and I can personally testify that the college is very serious when it comes to this particular issue, right? It is simply not tolerated, right? And let me just add that if you find yourself in that situation where you're being harassed in this way, you can report it to any employee at this college. And the employee will be obligated to report it to higher authorities, all right? Because we are considered to be mandatory reporters. In other words, if we get even a whiff of a rumor of any such thing happening of that kind, then we are obligated to report it. And the person who will ultimately deal with such issues is this lady right here, Dr. Miriam Begley, right? And again, there's another correction here because she was just promoted to, I forgot the name of the position, but she still deals with these issues when it comes to sexual harassment. So let me make a note of that correction here. Right? So she is the person who deals with all issues concerning sexual harassment, right? And I can tell you, I've got to work with her on all the issues, and she's a very nice person, very serious about her work, and I'm quite sure that if you go to her, she will deal with you fairly, all right? So her location is provided, and by the way, she's also, in addition to the new position that she was promoted to, she's what we call a Title IX coordinator. Title IX is basically that federal law which deals with discrimination practices at colleges and universities, right? So her location and her phone number and email address is provided. So if you have any issues, you can go to her directly if you don't feel comfortable going to a faculty member or any other employee at the college, all right? Okay, so that's as far as that is concerned. And then we have this document here. Basically, by completing it, you're indicating that you have read the syllabus, you agree to it, you plan to abide by whatever it says, and that's it. So make sure you complete this before you leave here today and turn it in to me, all right? Okay, any questions about what I've just covered in the syllabus? Any questions? Okay, so if there are no questions, what I'm going to do next is show you where things are located in Canvas. So this is the homepage here. And by the way, I've included in the homepage the very same syllabus that I went through. Again, I have to make corrections, which I will, and then re-upload it here. From time to time, I may make announcements, right? So like I might tell you or remind you that you need to watch some videos for the next class, or I might not be able to come to class. I'll leave some instructions in the announcements. This is where most of the material that you're going to use will be located under the files link, right? So under the files link, I've posted the assignment, which we're going to do, lecture notes, which will be the PowerPoints that will be covered, excuse me, in the videos. The syllabus, same syllabus that we went through, is located here. And let's see here, tables, very important. Let me open that up to show you. There are several links here. The main table that you're going to use is this table right here, which contains stuff like the periodic table and conversion factors, list of common ions. That's it right there. As I said before, I'm not a big fan of memorizing stuff, so that's the reason why I'm providing these tables. You will have access to these tables while you're doing your test, for example, right? So you don't need to memorize common ions or conversion factors or whatever, right? Going back to files, let me close this out. No, this should not be here. There are some other tables as well, which I'll get into later on in while we're doing the course. Go back to files here. So table. Oh, so in addition to the assignments, I'm also going to publish the assignment keys, right? So basically what's going to happen is that you complete the assignments and then I grade them, I send them back to you electronically, and then also I'm going to post the answer keys in that folder so you can compare your work to the answer keys. If you have any issues, any discrepancies, if you think I've graded something incorrectly, please let me know. And if you can prove that I've made a mistake in, grading something or adding other points, I'll make the correction and take care of that. Okay, what else? Is there anything else here? I have some past test keys. You can look at them to get a feel for your tests. And I'm going to also publish the test answers. So after you do your test and I've graded them, send them back to you, I'm also going to publish the answer keys for those tests. All right. So I think that's pretty much it as far as the files are concerned. The only other thing that's left would be where the videos are located. Remember, every week you're going to be watching videos and then you'll be coming to class to solve problems based on the topics covered in the videos. So the videos are located under the modules link. So when you click on that link, this is what you're going to get. Now, even though I'll be teaching directly for chapter 1, I've also produced a video for chapter 1. And so let me publish that now just in case you want to review that. But there are other videos for chapter 2 and the other chapters. And these are all YouTube videos that I've created, right? And so this one goes all the way down to chapter 14. And that's pretty much it as far as the modules are concerned. Yeah, I don't think there's anything else I need to discuss concerning the modules, all right? Okay, so again, let me stress, this will be a standing arrangement. You need to watch the videos, and then class time will be used for answering any questions if you don't understand, a particular topic covered in the videos, but also we'll be doing problem solving in this class as well, all right? So we'll be working on the assignments during class time. Okay, any questions about the Canvas shell for the course? Any questions? No questions?
Excuse me?
Yes, ma'am.
I can't find the evidence of understandment file.
That would be on the syllabus, the very last page. Let me see, hold on. You see this? That's the last page. You're going to sign that, you're going to complete it, and you're going to submit it to me. What I can do is, since you are online, I'm going to do this. I can create a Dropbox. Let me see here. I think Dropbox is already created. Okay. Oh, it's already there. So you can basically submit that evidence of understanding in the Dropbox provided. Let me just check something here. Just to make sure everything is. Okay, yes, so Yes, you should be able to upload it into that Dropbox. You just go to assignments and look for the evidence of understanding link, and you upload your page completed into that Dropbox. So I hope, I don't know who asked that question. I hope that answered the question, Miss
Thank you.
King. Okay. All right, so if there are no other questions concerning the Canvas shell, what I'm going to do now is go directly to the first chapter, Introduction to Chemistry. Right? So let's talk about what chemistry is. And as you can see on the screen, chemistry is the science of the composition, structure, properties, and reactions of matter, especially of atomic and molecular systems, right? So that's what chemistry is by definition. So at the heart of chemistry is matter. What do we mean by this term matter? Matter is basically anything that has mass and volume. Anything that has mass and volume, we call it matter. So basically anything that's material, right? So as we said in the definition, there are a couple of things that we're concerned with when it comes to the study of matter. One thing that we're concerned with is the composition. The composition is basically the makeup of a particular substance. Basically the different elements that make it up and the relative amounts of those elements present. The other thing that we're concerned with is the structure of matter. What do we mean by that? Basically, and this is at the microscopic level of atoms and molecules, we're concerned with how the different particles are arranged, how they're connected to each other and so on, right? The next thing that we're concerned with are the properties. So this term properties in chemistry, and to some extent in physics, basically what it means is the defining characteristics, right? So things like color, taste, density, mass, all those things that basically help to define the substance. We call them properties, right? And later on, we're going to learn about two types of properties, physical and chemical properties. And then the last thing that we're concerned about is basically the different types of chemical changes that matter will undergo. And we try to understand that based on the previous issues or topics that we mentioned. We try to understand that in terms of the properties being displayed, the structure especially, what happens at the atomic stage, and the composition. So that's basically what chemistry is all about, right? And in my opinion, and of course I'm biased, chemistry is the most important scientific discipline there is, right? And what you'll find is that other scientific disciplines like biology and physics somehow have share some common interest in topics that we deal with in chemistry. So chemistry is what I consider to be an essential science because it is connected to other sciences, right? For example, if you're pursuing a biology degree, you have to do some chemistry courses, right? If you're pursuing a physics degree, again, you have to do some chemistry courses, right? As far as I know, if you're doing chemistry, you don't have to pursue any biology courses. You can if you want to. I think you have to do some physics. But what you'll find is that there are other fields which basically involves chemistry, such as engineering, well, biochemistry, obviously, toxicology, medicine. I mentioned physics already, material science, nutrition. So all these different scientific fields have some chemistry aspects to them, all right? And even non-scientific areas such as law, business, and so on. Chemistry is involved in a lot of these cases. For example, if you have a chemistry degree, you can actually get into law school and you can pursue patent law. I know of one person who have actually done that, right? Where they look at patents that are sent to the patent office of inventions and they examine it to see, make sure everything is dotted in terms of the I's and crossed in terms of the T's and so on. So chemistry is essential science, and chemistry is involved in everything in our everyday lives. Chemistry is very important, right? Our very lives, survival as a human species involves, for example, certain chemical reactions taking place in our bodies, right? Now we're going to take a bit of a detour here because I want to talk about the scientific method, which is a method that is used by scientists all over when it comes to investigating, a particular system or, whatever their research interest would be, all right? So the scientific method is the step-by-step process that is used to explain observations in nature, all right? So what we're going to do is go through the steps involved in the scientific method so that you have an understanding of how it works. Now, the first step in this process is what we call the observation. This is where you use your senses, your eyes, your ears, and so on, to observe what is happening in a particular system. So you're going to define a problem by recognizing it, and you're going to state it clearly, right? The next step we call the hypothesis. And the hypothesis is basically a tentative, kind of speculative explanation for what you observed in the first step, right? Now, please note that this is basically some idea that you come up with. It has to be reasonable, nothing, outlandish. But basically, it's an explanation which is reasonable, and it serves actually the basis for further experimentation, because the next step involves testing the hypothesis, right? And in the natural sciences, the way we test the hypothesis is by conducting an experiment. So the scientists in this particular step would have to come up with an experimental design, and the purpose of that experimental design is to make sure that the hypothesis fails if the hypothesis is not true, if it's not the true explanation for what is observed in the first step, all right? And this is where most of the hard work of the scientists will come into play. So the scientists will perform the experiment, we'll get data and other information from the experiment, and basically we'll look at the data from the experiment to see if it is as predicted by the initial hypothesis. And usually in the initial stages, there will be some disparity between the experimental data and the original hypothesis. So the question now becomes, what do we do? And the answer is that we basically go back to the hypothesis and either change it or replace it with a new hypothesis. And then you carry out further experimentation to test the new hypothesis. And this back and forth will take place between the hypothesis and the experimentation. So as stated here, steps 3 and 4 will be repeated until the hypothesis successfully predicts what will happen. In other words, you will have some harmony between the resulting experimental data and the refined hypothesis, right? So basically, when you get to that stage where the hypothesis successfully predicts what will happen based on the data provided, then you can come up with a statement which is a scientific law, right? And in chemistry and physics, usually that law is in the form of an equation, even though it can be expressed in words as well, right? Now, the refined hypothesis, right? The one that is backed by repeated experimentation, data and all of that, that now is no longer a hypothesis. We call that a theory, right? So it's important that you understand the difference between the hypothesis and the theory, right? The hypothesis is the original speculation statement about why you think what you observe is what you observe, right? The theory, on the other hand, is backed by the weight of evidence as a result of testing the hypotheses repeatedly until you end up with a situation, as I said before, where the data fits what the refined hypothesis is, and therefore that hypothesis becomes a theory. So as stated here, the theory is backed by the data arising from repeated experimentation, all right? So that's basically how the scientific method works. But believe it or not, this is not the end of the story, right? So this is a flow chart here, basically going over the same thing as I mentioned before. You have your observations, then you come up with your hypothesis, you test your hypothesis using experiments. If the experiment proves that the hypothesis is not true, you have to come back up here. You have to either replace the hypothesis or make, certain modifications to it, do further experimentation. You do this over and over again until the refined hypothesis becomes a theory, right? But this does not necessarily represent the end of the story, because if you look at this history of science, what you find is that there are periods where you might have a theory that is widely accepted by everybody in the scientific community, and then one person tinkering in a lab somewhere comes up with evidence which completely obliterates the accepted theory, right? So that's why there's a further step here which says further experimentation, right? So people are always trying to test established theories to see that the theory will stand up to those tests. And if the theory does not stand up to the test, then guess what? You basically back up here again, and you go through the same process again in order to get a new theory which explain the data arising from further experimentation. And as I said before, there are several instances in science where that happens. One example, is let me introduce slide here. One example of this, my favorite example of this, is back in the day, I don't remember exactly what century this was, but there was a theory that was widely accepted by the scientific community, especially in chemistry, known as the vitalistic theory. The vitalistic theory. All right? And basically, that theory says that in nature, there's this thing out there known as a vitalistic force, which is responsible for the production of naturally occurring compounds, right? So those compounds that you can isolate from plants and animals and so on, it was believed back then that there's a vitalistic force which is responsible for making those compounds. And as such, we as human beings cannot make those compounds. That's basically what the theory says, right? So one guy by the name of Frederick Wöhler, he was from Sweden. So there are two dots over there. He was trying to make this compound, and the name of this compound is ammonium cyanide, NH4OCN, right? Now, he wasn't trying to prove anything excepting isolating this compound, right? And he did several experiments before this, ended up with the ammonium cyanide in an aqueous solution, right? Now, typically, if you have an ionic compound, and later on we're going to talk about the difference between ionic and molecular compounds, but I'm just going to mention this. If you have an ionic compound dissolved in water, right? Typically, to isolate that compound, what you do is you'll heat the solution, drive the water off, and what will be left would be your ionic compound in the form of solid, right? And that's exactly what he tried to do. He was heating this solution, but instead of obtaining this, he obtained this compound, right? So a chemical reaction actually took place. The name of this compound is urea, right? Now, can any one of you here tell me where in nature do we find urea?
You say urea?
Urea, that's the name of the compound.
In urine?
In the urine of mammals, right? Cows, goats, human beings, and so on, right? And this particular reaction is the first recorded instance of a naturally occurring compound made from something that's not naturally occurring, all right? So as a result of the discovery of Mr. Frederick Wöhler, that signals the end of the vitalistic theory, even though it's a theory that was accepted and assumed to be true for a long time. But because evidence has been produced, which shows that, well, we can actually produce this compound in the lab, even though it's also produced in nature, then basically that means that the vitalistic theory is no longer seen as a credible theory, all right? So that's one example, and there are several examples that I can point to. The thing about this particular example, the ironic thing about this example is that Frederick Wöhler wasn't trying to prove anything, right? He was just basically trying to isolate his compound, and he accidentally basically destroyed the vitalistic theory. Okay, so let me re-emphasize what I mentioned before about the difference between the hypothesis and the theory, right? So The hypothesis, as I said before, is basically a tentative explanation that you come up with after making an observation, and it forms the basis of further experimentation. Of course, experimentation is to test it, and then after repeated testing and changing the hypothesis or replacing the hypothesis, you're finally going to end up with a theory, which is basically a well-established hypothesis, because you have evidence, usually in the form of data, to back it, all right? And then we need to make a distinction between these two and what is called a law. The law is basically a statement of what we observe, right? For example, there's one law that you're going to meet later on in chapter 30, Boyle's law, right? Boyle's law talks about the relationship between the pressure exerted by a gas and the volume. And according to Boyle's law, the pressure of a gas is inversely proportional to the volume if the temperature and the amount of gas is constant. That is observed in every situation, right? There's no exception to that particular law. In fact, for those of you who have to do general chemistry 1, or if you're going to do it with me, there's one experiment which deals with Boyle's law, and you're going to see how that works, right? So the key thing I want to say here is that the law is different from the theory, which is different from the hypothesis. The law is basically a statement. The law is not an explanation, right? The explanation lies in the theory, all right? The hypothesis is a tentative explanation, but you don't know whether or not it is actually true in terms of representing what explains the observation, because it has to be tested. After you test it repeatedly, then you get the theory, which is more credible because it has data backing it. And then you have the law, which is basically a statement. The law is not an explanation. The explanation would be the theory. Okay, so that's basically that. And then here we have a side-by-side comparison between the hypothesis and the theory. Again, just re-emphasizing what I just said. Basically, it comes down to what we have here at the bottom. The difference between the theory and the hypothesis is that the theory has evidence to support it, while the hypothesis is just basically a tentative, kind of speculative statement explaining what is observed in the first place. Okay, so believe it or not, in our everyday experiences, we have employed the scientific method in solving problems in our everyday lives, right? So I'm just going to use one example here just to show you that the scientific method is how we go about solving problems. So let's say you want to play your favorite CD. So you put your CD in the CD player and the sound is skipping, right? So in the scientific method, that would be your observation. So my question to you is this: what's the next step according to the scientific method? After observation, what do we do? I'm sorry? Very good. So what would be the hypothesis you would come up with in order to explain tentatively why you observe what you observe? Yes, sir.
That the lens of the CD player is dirty.
Okay, so you're saying there's an defect in the CD player, basically, right? Okay, is there another possible hypothesis you can come up with to explain what is observed in the first thing? He's saying that there's something wrong with the CD player. Is there another possible hypothesis to explain the fact that the CD skips when you try to play it?
There's something wrong with the CD.
There's a defect in the CD. Very good. All right. So we have two competing hypotheses here. So let's see which one comes up first. Okay. So what he is saying about the CD player, right? Not working properly. That's one hypothesis. So the next step is what, according to the scientific method? Yes.
Experiments testing.
Okay, so how would you carry out that test? How would you test for the CD player being the issue? Come on. How would you test if the CD player is the issue? Yes, sir.
Try it again.
Try what?
Try playing it again. Taking it out and put it back.
Okay, so let's say you get the same issue. Yes.
Try with brand new CD.
Take another CD, put it in there, and see if the same issue arises, right? So when you replace the CD with another one, in this particular case, everything sounded okay, right? So therefore, hypothesis one, well, the theory, let me say this, is that the player is not the issue. The player is working fine, all right? So let's move on now to the second issue or the second hypothesis, that it is the CD itself that is defective. So how would you test this particular hypothesis? If the CD is defective, how will you test to see if that is so?
Put in a different CD player.
And let's see what happens, right? So you have to do your experiment where, as he suggested, you put your CD in another player. And what was observed in this case is that the sound still skips, right? So the conclusion we can come to in terms of the theory is that it is the CD that's the issue and not the CD player. So admittedly, this is a simple example, but this illustrates basically how the type of thinking that is involved in a scientific method, right? And this is a process that scientists use. Of course, not in simple examples like these, but basically when it comes to advanced research and so on, all right? Okay, now, one thing I want to highlight here, which is very important. I don't know what your career plans are, but if you plan to work in the sciences, it's very important. In fact, let me go back to this slide right here, that you exercise integrity and honesty in your practice. Now, remember this flow chart right here. Oops, right? And remember what I said about this section right here. Remember I said that once you get your data, right, if your data does not fall in harmony with the hypothesis that you came up with originally, then you have to come back up here and you have to revise the hypothesis, all right? What you should not do is change the data to fit the hypothesis, all right? That is basically scientific malpractice, and in some cases, there have been serious consequences as a result of people doing that, right? So remember, when you are doing any experiment, and if the experiment doesn't fit the hypothesis, you modify or replace the hypothesis with another one to fit the data. You do not change the data to fit the hypothesis, all right? Now, there are a couple of examples of some negative consequences, and believe it or not, you have high-level researchers committing those infractions with serious consequences. I have two links here. Let me open up this one here. Now, this one is not as serious. In fact, you know what? Let me go to the other one. Sorry. Okay, where's that? Okay, let me go to this one. No, shoot. Because this one resulted in a researcher ending up in prison. Okay. The link is still active. Oh, shoot. Let me see here. Okay, so basically, this vaccine researcher ended up in prison for committing research fraud. All right. Now, let me just give a brief explanation. When it comes to the, top universities, research universities like UF and Harvard and all that, there's an issue of funding when it comes to researchers trying to do their research. And there are two main sources of funding, unless the person is independently rich. One is the government, and the other is private sources like companies and so on, right? When it comes to the government handing out money, there are strict rules concerning, using the money for research purposes, right? So, and of course, they have to report their results to the government agency that is responsible for funding their research, right? Now, this guy here, don't know how to pronounce his name, Dong Pyu Han. He was engaging in research. I'm going to try to find exactly where in the article he actually committed the infraction. So, oh, and another thing I want to say here. So, what you'll find, and I remember the first time I found this out, I was kind of shocked, is that if you get money as a researcher from a company, or from the government, I should say, and you committed some infraction in terms of being honest or integrity exercise in your research, then you can be banned from getting more money for a certain period of time. So you can have a 2-year ban, 5-year ban, and so on, right? Now, I've never heard, up until when I read this article, of anybody going to jail committing research fraud. But this guy here, he's a former biomedical scientist at Iowa State University in Ames, and he was sentenced to 57 months for fabricating and falsifying data in HIV vaccine trials, right? And he also has been fined $7.2 million and subject to 3 years of supervised release after he leaves prison. And if I remember correctly, I don't remember if it's in this article or some other article, the main reason why he ended up in this trouble was because the amount of money that was involved was above a certain threshold. So if it was below that threshold, then you'll get banned for 2 years, 5 years, whatever. But if the amount of money you receive is above whatever that threshold is, then we're talking about prison time, right? So let me get to the actual infraction that he committed, which is, I think, in this paragraph right here, and was forced to resign from Iowa State in 2013 after the university concluded that he falsified the results of several vaccine experiments supported by grants from the U.S. National Institutes of Health. In some cases, hand spiked rabbit blood samples with human HIV antibodies so that the vaccine appeared to have caused the animals to develop immunity to the virus, right? So that's basically the main thing that he did. Because if he did spike the rabbit blood samples with antibodies, then he should have reported that. He didn't. And the reason why he did it, because he wanted to look like the treatment that he was coming up with to treat the virus will produce more antibodies, which is not the case, right? And he admitted to it, right? As you can see in the next paragraph. In a confessional letter sent to the university just before his investigation concluded, and said that he began the subterfuge to cover up a sample mixer that he had made years before, right? So as a result, he ended up in prison. So this is just one example of a situation where somebody committed scientific fraud and end up paying a huge price for it. So that's very important. If you practice science, if you plan to practice science, it's very important that you don't engage in any type of fraud in order to get the results that you want. The results is just basically the results. You don't make changes to it. Basically, you can go back and improve things so that you get better results. Okay. The other example is not really that serious. This lady, very talented, bright person, she won a Nobel Prize along with 2 other scientists. And after that, she had to retract a paper. Now, the paper is based on this topic here, enzymatic synthesis of beta-lactam. And the reason why she had to retract it, and this is another important aspect of science or science's practice, is that she published the paper with her results, and other people were trying to reproduce it. And this is basically common practice. If you publish your results, you include in your publication the methodology and so on, then any other scientist should be able to do the same method and get pretty much the same result. That did not happen. In fact, it says here that the reason why the article has been retracted is because the results are not reproducible, and that's very important, all right? And one unique thing about this particular situation is that usually the retraction is done by the publication. But in this case, it is the instructor or the researcher herself who retracted it, right? Because after questions came up about the lack of reproducibility of the results, then she tried to find the research notebooks. Let me see if I can find where she said that. What's going on here? This thing is stuck. Okay, I don't know what's going on here, I'm trying to scroll down, but it's not moving. But basically, as stated here, she said, and remember now, she was a Nobel Prize winning scientist, right? It is painful to admit, but important to do so. I apologize to all. I was a bit busy when this was submitted and did not do my job well. So she admitted that something went wrong. And therefore, as a result, that publication has to be put. In this particular case, the important takeaway is that it doesn't matter who the scientist is. It doesn't matter if it's a Nobel Prize winning scientist. If the results are not reproducible, then her work is basically not seen as legitimate, right? Okay, now what time is it? 12:10? All right, so what I'm going to do right now, since we're finished with this chapter, I should have it here. I'm going to give you your first assignment to work on. So on your way out, by the way, did everybody sign the sheet? All right, so on your way out, make sure you pick up a copy of this assignment. And if you have any questions between now and next week about the assignment, feel free to contact me by email or by Skype, preferably. And remember also to watch the videos for next week. And we'll get started on those. For those of you out there in Zoom, let me check and make sure that I've published assignment number 1. Okay, so let me do that right now. So assignment number 1 is published for you guys out there in Zoom, so you can download it and complete it and submit it online. Before I forget, let me oh, and of course, the evidence of understanding sheet, make sure you turn it in.
Yeah.
Okay. Cool. Yes, ma'am. Okay, so, yeah, so let me explain what's happening here. For the testing center, all you have to do is call, I'm gonna talk about that later. When you call there, oh no, actually, they have a different system. You can go on your website and schedule an appointment to do that test. And I will give you a week within which to do that test. So like I'll announce like a week before, you can go ahead and sign up.
Before that.
Exactly, and you can choose that, and you can do that any one of the testing centers at the Citrus, Levy, or Ocala campus.
Perfect, thank you.
Yes, ma'am. Yes, sir. Yes, sir.
I can't like declare it's my precious morning.
Oh.
And I had a partial card. But what is on the testing for the.
Right, so the tests will be done in the testing center.
Okay, we don't have any, what test we have coming up or anything?
No, well, the first step is what, in February, early February.
Okay,
I
I didn't,
mean, so basically what, as I was telling her, what I'm gonna do is, the week before the test, I'm going to let you know that the test is coming up.
okay,
You can sign up with any of the testing centers, you can go online and sign up, and then you're gonna have a week period within which to do that test.
Okay.
And then I'm gonna grade it and get it back to
okay,
you.
yes, also, you do online, like I can join Zoom. right?
Oh, yes, you can join on Zoom, yeah.
Like instead of coming in person, cause I come from Ocala right now, I don't have a car, I don't know how long. it's gonna
Oh,
take
okay,
to get it
yeah,
going.
yeah. Some of the students, as you can see, there are some students who have joined on Zoom.
Okay, that's good.
So,
Okay.
yeah, you can join on Zoom. So
Where is the link at, or? where-
well, the link is, if you go to the Canvas shell,
They should,
and let me show you.
yes.
If you go to the Canvas shell, you click on Zoom.
Yeah.
And then you're gonna see the link for like this link here.
Okay,
You press start
Yes.
and that's it,
okay, thank you,
all right?
thank you, have a good day, I
Yeah.
appreciate it, yeah.
You too.
My apologies back there.
Yeah, no problem. no
Thank
problem.
you, have a good day.
Yeah.
So I just thought, for the exams,
Mm-hmm.
do we have like a range of dates that we have to do?
Right,
by?
within 1 week, right?
Oh,
So basically, like I was telling him earlier,
Oh,
I will let you know like a week before. Your test is next week, so go to the website for the testing center
yeah,
and sign up for the test, and you have within that week to do that,
okay, thanks.
right?
Great, yeah, so it's like, if I do it online, if I join the Zoom meeting, I'll still be kind of as present.
Oh, yeah,
Okay.
definitely,
Okay,
yeah.
thank you, sir.
Yeah, no
Have a good
problem.
day. Thank you.
Mhm. Okay, and for you guys out there, oh, there's a chat message here. Oh, okay, don't worry about the attendance, since you guys out there in Zoom, I'll have a record of your attendance. But yeah, that's it for today, folks, so I'm gonna sign off now.